Yeah, thanks in advance. So my project is the clothing recommender system. And about me, my name is Sally. I studied biomedical engineering at the Johns Hopkins University, and I'm currently doing my master's at UC Berkeley. Currently, I'm working at a medical image viewing and storage solutions company, so kind of different from deep learning. So I'm new to it, and I learned a lot this month. Felt like a crash course. So a question what I wanted to ask is, what is fashion? And I kind of touched upon this the midterm, but maybe you guys on this side haven't seen this slide yet. So this is Justin Timberlake in 2001, and then this is Justin Timberlake in 2013. Yeah, it looks kind of weird, right? How would you describe it? Like, why does the left one look really weird? So that was my question. What makes an outfit work? So we kind of have intrinsic knowledge what works. And how can we translate this knowledge to computers? So motivation. This topic is very interesting because fashion is an evolution. So depending on what's trending, the results can be different. So this was the 80s. I don't know if you guys want to wear this right now. This was the 90s. And this was the 2000s. And then we're 2017 right now, so I guess what you're wearing is right now. So I actually used 2 data sets to complete my project. So the first one is deep fashion. So deep fashion actually has 4 categories, and they're called category and attribute prediction, consumer to shop, fashion landmark, in-shop retrieval, and it had about 800,000 images total. I actually only used 2 out of the 4, so around 300,000 images. So this is kind of what the data set looked like. Different images, and like it has pointers to where like the sleeves are, etc., landmarks. And the second data set I used was MBC. I had to contact the people directly, and luckily they responded to me with the link to download. And it had 161,260 annotated images, as well as 264 attribute labels. So this is kind of what the data set looked like. They had different images of a person facing forward, left, back, etc. Now, this is my envisioned workflow. So you would input a database of fashion styles you like. So this is what I would call the reference. And then you would input a database of the clothes that you currently have on hand, which I would call the closet. And the system will tag the reference and closet clothes with the attributes, as well as label if the clothing piece is top or bottom. And the reference database values will populate a cross matrix, and the user will be able to input an image, top or bottom, and the system will display a list of recommended counterpart based on the cross matrix. So that's what I envisioned. So this is how it looks like kind of in a picture. Okay, never mind, it doesn't work. So on the left side, top, you see that your reference and closet clothes goes into this first neural network that tags it whether it's up or bottom, and then it crops it, and then depending if it's upper or lower, in part 2, I would tag the attributes. And based on those values, I create a cross matrix, and the user queries a clothing. The cross matrix is made from the reference, and I would spit out a recommendation. So this is a visual representation of my workflow. So part 1, to go over the background, the difference between object classification versus detection. So the left one is, it looks at the whole image and it says it's a dog, whereas the right one, it can pinpoint certain regions of interest and then say it's a dog. So that leads me to my next point, region proposal. In non-technical terms, it just finds blobby image regions that are likely to contain an object. So this is what you call a region proposal. So there's something called slow RCNN, fast RCNN, and faster RCNN. So this is kind of the research that's been going on. So slow RCNN comes out in 2014 with selective search, and then it required a forward pass for each region proposal, meaning 2,000 times per image. So the next people said, hey, we can actually just do it once. Use a fast RCNN to use a single network to compute And then someone came in 2016 saying, hey, I can make it even faster by removing the selective search. So this is kind of like the benchmark that you would get. If something takes 50 seconds for RCNN, it would take 2 seconds for a fast RCNN and 0.2 seconds for a faster RCNN. So the background I'm giving you this is because I decided to use the faster RCNN for my object detection. So my data prepping, I used Deep Fashion's notation. They use up 1 to indicate upper clothing, 2 to indicate lowered clothing, and 3 to indicate full body. And I I wrote some Python to extract images and B boxes. B boxes is like the red boxes that you saw in the previous images for each category, and split the data into training and testing. And as I mentioned earlier, I only used 2 categories for this project. So faster RCNN uses a ResNet 50 network architecture. So I started weights taken from a model trained with the Pascal VOC set. And they were frozen up to the classification layer, and the last layer was fine-tuned for this project. And I ran it for about 80 epochs, and as you can see, the accuracy stagnated around like high 80s, maybe almost 90. So when I ran this is what it would look like. So each line would contain an image title and how long it took, and then what class it is, whether it's 1 or 2, and as well as coordinates for the bounding boxes. And here are some of the results that I got. So as you can see, it can adapt to various poses and backgrounds and colors, and it can tag multiple instances even in a single image. So that was my part 1 of my workflow, and part 2 was attribute tagging. I used the Inception V3 network, and it saved weights. This was provided by Google, and this was trained on the ImageNet data. So this is the overall architecture of it. I guess it's really hard to see. Okay. And I altered the final layer to a sigmoid-based classification according to my attribute base, because I kind of want probabilities for each one, how likely is it. And in order to use this, data had to be processed and organized so that all the images were in one folder, and each image had to have a corresponding labeled attribute tag list, and there's a master list of all these possible attributes. So that was a lot of data cleaning right there. Yeah, so the original attribute list was 1,000, and I whittled it down to 20 attributes and 20 categories each. As you can see, all these things, there's huge imbalance of data. Like towards the top, it's like about it can get up to 6 times more than the lower ones. And so I had to oversample the minority classes to get better results. So this is kind of me trying to balance the data set. So this is the results I got. So you see this image. This cropped it as an upper, and afterwards it said that it's most likely to be lace. Its material is chiffon, long sleeve. Said it was floral, and I guess it saw a little denim in this picture. So it's okay, not great, but it's okay. And then so for a lower one, it said it had stripe, which is correct, pencil, I can see that, and then knit, mini, and zipper. So these were the top 5 attributes tagged for this image. So now, part 3. So part 3 really depended on how well my part 2 was going to go, and I felt like my part 2 wasn't really at the point where I thought part 3 would be accurate. I was working on this assumption that more frequently occurring top and bottom pairs would be more recommendable. So my original plan was to populate this matrix according to the results of the previous part, where I used the fashion landmark portion of the deep fashion data set. But the tagging wasn't as accurate as I hoped to be, and the matrix was a little too sparse to have any material meaning. So I made a proof of concept model where I used data from the MVC dataset, as it was less sparse and more organized. I retrieved column and row names for the crosstabs, and there was 123 rows and 125 columns. So these were upper and lower respectively. And just for the demo, I populated the matrix using random integers, so this is kind of what it looks like. So the top column names, you see blouses, blue, vertical stripes, etc. At the left, you see the row names like animal print, etc., like things you would use for your bottom. So I wrote this thing where you input a file name. Well, if you put none, I picked a random one for you. And it tells you if it's a top and then what attributes they are. And then it spits out what bottom should be according to what happens most frequently, what traits come up. So these were the traits that came up, and then it shows me the picture that is most matched with that attribute. So this is if my input is top. This is what happens when my input is bottom. So for here, the bottom was like denim, gray, polyester, and it says that it looks good with something that has a zipper and pink. So go. So this is my overall workflow. So my contribution I think I made in this month is the implementation of a potential workflow for a clothing recommender system. So I did that by doing object detection of tops and bottoms using faster RCNN and attribute tagging using CNN, and proof of concept of a recommender system based on frequency counts. So the first part was so that someone can input an image of a whole model that's like in the street, and so it would be able to detect regardless of what the background is. So it's kind of an addition to being able to correctly take out and crop the clothing for the part 2. So here are some of the ideas that I had for the future. So for higher accuracy, obviously cleaner data set will result in higher accuracy. So I'm thinking maybe separate clothing into men's and women's and differentiate styles and trends, like for example, classy or casual. And if I had all the time in the world, I would want to rebuild the network architecture to accommodate like mutually exclusive qualities such as like sleeveless, short sleeves, and long sleeves. And then train on different data sets by quality to address the data imbalance issue, and then maybe use a softmax for quality. And experiment with the normalization of frequency counts in the cross matrix. And the another part I had was business ideas. So that's also a huge question with every project. What is the implications? What are the applications? How might you make money out of it? So similar workflow to expand to other pairings. For example, if I was given a dress, what kind of shoes would go well with it? If I was given a tie, what kind of pocket squares would go with it? It doesn't even have to be pairs. Maybe it can be scaled up to do a 3 or more item ensemble, such as like a top, bottom, and a handbag. And obviously, if you're going to make it commercially viable, you want to add parameters and filtering abilities to match user preferences. Like users can manually adjust weights to certain attributes, perhaps like a feedback system. And scalability, maybe users can upload different data sets of closets, like what they have on hand, or references like of different styles to get various results from their query. So here's the list of my sources, and I just wanted to give a special shout out to my mentor for his patience, guidance, and moral support throughout this month-long project. And thank you for your listening. Stay on my project.
Yeah, so any questions? Comments? You raise your hand, right? No? Yeah, okay. Over there, sorry.
Could you consider using the model space as well? So like, if you look like this, you'd be most likely to be seen. If you look like this, you'd be most likely to be seen wearing these clothes.
I mean, I think that's another step you can go. But like what I learned here is data is so important. So if you have the data, it can work. But you need the data.
Yeah. Somewhere. Yeah, we have warehouses for it.
Okay, any more questions?
Just a bit curious for the faster sort of scales and areas that you use for the unders?
Sorry, can you repeat that?
What sort of scales and areas that you use for the under boxes and class R scale?
If you're talking about training, the data set had already had labeled.
I mean the anchor boxes, so for region proposals.
Sorry, I don't think I'm understanding your question.
We first proposed regions for the detection portion of the network. Typically, you would have predefined proposals for bounding boxes. And we would have a preset number of scales and areas for these bounding boxes.
You're saying what's the number of
Right, and what are the sets, scales, and areas used for proposing for regions? For a class or
I'm not quite sure if I'm understanding your question correctly, but I set my system so it can detect. You're saying what's my limit to how many boxes it can detect?
essentially, yeah.
So I did experiment with it, but then because of my data set was pretty, like, it just had really 1 or 2 people at most, I set it to like 5 just for speed. Okay. I'm so sorry. I wish I could give you a better answer, but I'm not sure if I'm 100% understanding it.
Yeah, maybe we can take that offline.
Yeah.
Any more questions? Okay, on the back.
I actually read your later proposal on progress, and it said that you like to add college attributes before doing the course training and stuff. And was there like a difference between that?
What is the difference of doing
And
this?
so I mean, how to say? So what's the purpose of doing that culture?
Collecting the attributes before I do. So that's the point of the number 3, because I made the assumption that if it occurs more frequently, it is more likely to be recommendable, and I need to collect what kind of combinations occur frequently with the top and bottom to be able to create a more accurate matrix to spit out more accurate results. So if you remember the very first picture that I showed with Justin Timberlake, nobody wears denim, and that's why it looked kind of weird. So that's kind of the assumption that I'm working on. Usually if you wear like a plaid shirt, you go with like a, solid colored pants. So that's a huge assumption that I'm working on, but I think it's a valid assumption. And that's why I also mentioned that I would want to experiment with normalizing the frequency count, because obviously I can't do 1 to 1 to 1 to 1. So that's something that I would want to